Well, we're going to look right quick then here at another problem that you might be expected to solve. And this is a problem you may or may not remember us doing this back in chapter 1 or 2. But we solve these problems using quadratic substitution. Quadratic substitution, which is basically the idea. You have something that looks like this. Say e to the 2x minus 4e to the x plus e equals, or plus 3 equals 0. And, you know, we can't really solve it with any of the tools that we have in our belt right now. But what we'd like you to be able to do, and this is the idea of quadratic substitution, to take a look at this and say, well, you know, this really does look kind of familiar. So I'm going to take this middle term here, and I'm going to let u equal e to the x. Now, the reason I'm going to do that is because I can rewrite e to the 2x as e to the x squared. Right? I can write e to the 2x as e to the x squared, and then 4 times e to the x, which is already there, plus 3 equals 0. So the idea is now that I can substitute u for e to the x. So I've got u squared minus 4u plus 3 equals 0. So now I have a quadratic equation, which I'm completely capable of solving. U and a u, and that's a plus and that's a minus, so these are both minuses. We've got u minus 3, u minus 1. We've got u equals 3, or u equals 1. But I'm not trying to solve for u, right? I'm trying to solve for e to the x. So I'll substitute back, say e to the x is 3, or e to the x is 1. I can say, all right, e to the x is 3 to solve for x. Take the log of both sides, natural log of, or log base e of 3 is x. So x equals the natural log of 3. Or e to the x is 1. The only thing that satisfies that, e to the what is 1. Remember, b to the anything, or anything to the 0 is 1. That's an identity. So we say, all right, so that means x is 0. And you can solve that problem actually a lot quicker than you might think. Another application of what we've been doing here, you could actually solve with the principal, rate, interest, and all that kind of stuff. So you might have a problem that says, if I invest $25,000, you know, this would be a retirement question. If I invest $25,000 at 9%, that's a nice interest rate, compounded monthly, how long will it take what am I saying? How long will, if that's spelled, will it take for the investment to grow, say, to, I don't know, $500,000. So, if I invest $25,000 at 9% compounded monthly, how long will it take for the investment to grow to $500,000? So our idea now is we're going to go ahead and write our formula. A equals P times 1 plus R over N to the RT, not RT, to the NT. That's better. Let's not make that mistake. All right, now I'll go look at my information to figure out what's what. 25,000, that's how much I initially invested, so that's going to be P, my original principal. Then I've got my rate is 9%, compounded monthly, so N is 12. And I want to know how long till I get $500,000, so that's going to be my A. So now let's plug these things in and see what happens. 500,000 equals 25,000. 1 plus 0.09 over 12 to the 12t. And we get to solve for t. Isn't that exciting? Okay. So we got to get that exponent isolated. Let's get rid of everything that's distracting. This 25,000 out front is very distracting. So let's divide both sides by 25,000 right off the bat. Okay, so zeros cancel out. And I'm left over here with 20 equals 1 plus 0.09 over 12 to the 12t. And I hate looking at exponents in that order, so I'm just immediately going to go throw my exponent over here. The 12t equals 20. Now, this basically looks like the problems that we've been solving in this section so far. We've got an exponent. We need to get this power out of here, so we'd like to pull it out. Best way we know how to do that is take the log of both sides and to use the power rule. So we're going to do that. 12t equals 20. So let's go ahead and take the natural log of both sides. So now we can apply our power rule. 12t times natural log of 1 plus 0.09 over 12 equals natural log of 20. Now since this here is just a number, I can combine it with this that's just a number and put them out front together. 12 natural log 1 plus 0.09 over 12t equals natural log of 20. And since again this here is just a number, this 12 natural log of blah 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 is just a number, so I can get rid of it by dividing it out on both sides. So like that over 12. And now I've got this in no way beautiful equation. T equals the natural log of 20 over 12 times the natural log of 1 plus 0.09 over 12. Now supposing you get this far, which you certainly have since you're here, we hate to do all this work and then plug it into our goofy calculators wrong. So let's make sure we got this. But what I'm going to plug into my calculator, I'm going to do the log of 20 divided by the whole thing on the bottom. So you want to make sure you have your external parentheses going on there. So I've got 12 times natural log of 1 plus 0.09 divided by 12. Now we don't need parentheses around there because it's going to follow order of operations. It'll automatically do the 0.09 over 12. So let's plug this in our calculator and please, please, please let us get something reasonable so we can go home and don't have to do this problem anymore. So say we got natural log of 20 divided by, big parenthesis, 12 times natural log of 1 plus 0.09 divided by 12, close that parenthesis, close the last parenthesis, and please, please, please be something reasonable. 33. So that's kind of sort of reasonable. If I invest $25,000 now, in 33 years, I'll have $500,000. So I could totally go for that. So 33 years. We got a reasonable solution. We're reasonably happy and reasonably confident to go do lots and lots and lots of homework problems. So enjoy.